Hey, welcome back. I am so glad you are here. I am Tammy and I do math for coffee, and we are doing one of my favorite things, proving trig identities. Secant x cotangent x equals 1 over sine x. My attack strategy on this one is just to change everything into sines and cosines because I know I'm trying to convert this thing into something that is just sines. So start with the secant x. Secant x is defined as 1 over cos x, and that's being multiplied times cotangent, which is defined as cosine over sine. Well, looking at this multiplication, you can see that the cosines are going to cancel out, and ta-da, we're done. 1 over sine x is what I got, and it's supposed to be 1 over sine x. Yay! This one looks a little more intimidating. Same attack strategy. Turn everything into cosines and sines, but at the very beginning, what I'm going to do with this first one is I'm going to split that one fraction up into two fractions multiplied together. So I have 1 over secant squared x times 1 over cosine x, because 1 times 1 is 1, breaking it up into two smaller pieces. Makes it easier to work with. 1 over secant x is actually defined as cosine. So 1 over secant squared x is just cosine squared x. And 1 over cosecant x is actually sine x, and we're done. Again, I'm going to switch everything into sines and cosines. Cosecant x on the top gets rewritten as 1 over sine x. Now we move to the denominator, cotangent squared. Well, cotangent is tangent flipped upside down, so that's going to turn into cos x over sine x squared, plus cosecant is really 1 over sine x, and that whole thing needs to be squared. We're going to leave the numerator alone for a second and just copy it over. In the denominator, we have to run those squares through, so we end up with cosine squared x over sine squared x plus 1 squared over sine squared x. So now we have a fraction in the top, but we also have two fractions being added together in the denominator, and those two fractions in the denominator have their own common denominator already. How sweet is that? So we have cosine squared x plus 1 over sine squared x. Now what you're looking at here is a complex fraction, and we're going to just divide fractions like we learned how to divide fractions way long time ago. If you need to review your basic fraction operations, I'll put a link up here in the corner. This is a fraction review that I made for people in upper level courses. So we're going to turn this into a multiplication problem. 1 over sine x is multiplied times the denominator fraction gets flipped over, so it's going to be sine squared x over cosine squared x plus 1. Now we get to do a little simplifying. We have 1 over sine x times sine squared x. I'm going to write it out. You probably wouldn't need to, but I'm going to just to be really clear on the video. Sine squared x is sine x times sine x. All of that is still over cosine squared x plus 1. One of those signs is going to cancel with the one that's in the denominator of the first fraction since we are multiplying. What we have left is sine x in the numerator, cosine squared. Oh, there's supposed to be an x right there. Cosine squared x plus 1. And that is exactly what we were supposed to turn it into. Yeah, it wouldn't be me if I didn't make dumb mistakes like dropping a variable off of a trig function. You're going to do it too, and I'm sure you're going to see your teacher do it. All right, we have cosine
cosecant
x times the quantity cosine
cosecant
x plus 1, and we need to turn that into sine x plus 1 over sine squared x. Rewriting cosecant to what it is with respect to sine, it's 1 over sine x times 1 over sine x plus 1. Distributive property, we're going to run that through. We end up with 1 over sine squared x plus 1 over sine x. Now, since we are adding fractions, we need to have a common denominator. You don't need common denominators when you multiply and divide, but you do need them when you add and subtract. So I have to multiply this second fraction times sine x over sine x so that I can have the denominators match, and that common denominator is sine squared x. We end up with 1 over sine squared x plus sine x over sine squared x. Sine x times 1 is sine x, and sine x times sine x is sine squared x. Now we have the common denominator, so we just need to add the numerators, and we end up with 1 plus sine x over sine squared x. Here is that fraction review video, and here is the playlist for pre-calculus. Click into either one of these. Thank you so much for being here. See you next time.